So today we have Tim Callaghan of VoltDB, who's here to speak with us about VoltDB using VoltDB as a developer. Thank you very much for coming, Tim, and
sure.
Feel free to start whenever. Oh.
As Shiri mentioned, I'm from VoltDB. I am the, actually I won't skip that slide, that's coming up next, who I am. Today I'm going to cover a couple things. First I'm going to do a kind of a sweet and condensed VoltDB tech overview. And as the field engineer, I support sales as one of my responsibilities. So there's an overview I do that's about a half an hour when we have a potential customer on the phone and we have technical people on the other end, not just a salesy call. I'm going to condense that down to around 10 or 15 minutes depending on how many questions come up, but I think it's important to lay a foundation for what VoltDB is, which will then also show you what it isn't. At that point, we'll do some comparing and contrasting to traditional OLTP. By traditional, I just mean MySQL, Postgres, Oracle, that type of database. I've got a couple slides on migrating and development issues that you might run into if you decide to grab a VoltDB and play with it. And then Q&A at the end. I run the Windows user group out in Waltham. I love questions. Certainly ask them as we go, interrupt me. If you're asking a question that I'm going to answer in a few slides, we'll defer it, but for the most part, I'll take you through any aspect of VoltDB you guys want to talk about. The one thing I can't promise to do is I've got a great fear of chalk and chalkboards, so I won't be, unless there's a whiteboard, I'll have to try to make you guys believe by hand waving. Do that sometime.
You'll have to open like Paint on some kind of Paint program on there.
Yeah, or that, or there's some big white post-its over there.
There you go.
So a little bit about me. I'm the field engineer and community advocate. We're a commercial and an open source company, so community is extremely important to us. Developing, getting people in our forums, getting people to contribute code, all things that are parts of our goals from a community side. I support both commercial as well as community customers. I've built more than I can count at this point, example apps and proof of concept applications using Volt in the past year. Technically, before Volt, I did about 18 years of Oracle, database administration, schema design, development, PL/SQL, SQL, hosting, all the fun stuff that goes with that. So I've had lots and lots of Oracle experience. Just a little bit of MySQL experience. One thing I can say is I met with someone about an hour ago before the meeting, a friend of mine who I hired in 2001, and he joined me from a startup. And his startup was using MySQL, and at that point I was using Oracle. And when we would talk about technologies, I think I kind of, as an Oracle person I kind of looked down at MySQL at that point, given, he would ask me, I would say, well, MySQL doesn't do subqueries, or MySQL can't do outer, there was functionality that wasn't in MySQL yet. You're going to see the same thing in Volt right now. We're at that same stage. We just released in May, so our SQL support and things of that, we're a V1 product. So it's kind of funny meeting with Adam today and thinking back to that when he first started at a company called CrunchTime with me, the way I looked at him, and I didn't understand, how do you use a database that doesn't have the ability to do these big, disgusting 50,000 line SQL statements? Who cares if it's that big? It should be possible. So it kind of all came back tonight and coming here. I'm also a user of many programming languages, certainly SQL, PL/SQL, database languages, but also Java, C#, C++, lots and lots of various projects that I've worked on with those. And on the last slide, plenty of contact info. If anyone wants to hit me up, get some ideas about Volt, whatever, everything's going to be available at the end. So diving into technology, before I begin, I put this slide in here because I realized as I did my whole deck, part of this deck came from our sales deck, and normally in a sales call, people already understand these two things. I wanted to make it very clear here. We're available both in a community, it's GPL3 licensed product, as well as a commercial edition. And we run on Linux and Mac. Mac has an asterisk, it's for development only. I think it would run fine, but if you want to get commercial support, we're not going to be supporting the Mac platform in a production environment. So Linux, anything with a 2.6.18 and above kernel, we test every night on CentOS 5.4 and 5.5. All our developers use Ubuntu. We've got Ubuntu servers. So pretty much any current Linux should run this just fine. There's a certain version of Java you have to have installed for some bugs that we've found along the way, but pretty much any Linux distro is just fine. We don't run on Windows. We never plan on doing a port unless someone in the community wants to grace us with that port. Don't think it'll ever happen. So oftentimes when I'm talking to customers or potential customers, lots of these traditional OLTP products, what they've done to try to scale is shard, and certainly sharding can improve the performance of your application. But it really introduces two drawbacks. One is from a management perspective, you've got more databases to back up and potentially recover. You've got more replication to keep track of. And then also, should you come time if you have 2 shards and you find you need more performance and you need to go to 3, there's a manual effort involved in resharding. I should have here resharding your data. I think normally you dump your data to disk, bring your nodes back up, and then shuffle the data back to the various shards. From an application perspective, there's complexity as well. Your apps need to become shard aware. If I'm going to send a transaction to one of my shards, I need to know which shard should get that transaction. If I'm going to do a join across 2 of these shards, how am I going to handle that in the application layer? I'm going to issue a SQL statement here and here, and bring it back, and then in my application layer, I'm going to do a unioning of the data. Lots of schemes to get that done. And then how do you actually implement a true cross-shard transaction? If I want to do an update in this shard and an update in that shard, and commit in both shards, what do I do when the first commit succeeds and the second one fails? How do I roll the first one back? Just very basic, can really increase the complexity of your environment. And then lastly, each shard is still going to suffer from that traditional performance limitation. You can only make a server so monolithic before there's no more available CPU or RAM to be put in that box or I/O performance. So at some point you're going to be sharding into yet another set of sharded databases. The last bullet I put up here for tonight, I talked to a lot of people who've already sharded. Maybe they're happy, maybe they're not. Absolutely, if you can shard your problem, if you can shard your database, your application is probably going to be fantastic in VoltDB. One of our concepts that we're going to go over tonight is what we call partitioning, very similar to sharding. But if you've already defeated the issues that you can run into with sharding on your personal applications, if you can do it in a shard, you can certainly do it in VoltDB. So how VoltDB came about? There's Mike Stonebreaker and some other researchers put out a paper at Sigmod 08 called OLTP through the looking glass. And what they did was they took an open source database called the Shore, S-H-O-R-E, and there's a link to the PDF up there. I'll try to make the presentation available for anyone who wants to grab it later. But what they did in that project was they said, let's take a traditional OLTP database, one that does, you can see on the pie chart here, there's buffer management going on in my database, there's logging for durability, and then there's latching and locking for concurrency, conflict, multi-version concurrency control and such. So they took this open source database and they implemented TPCC on it, which is a very standard transactional processing benchmark. And what they did, to come to these percentages, what they did was they said, okay, let's find out what is the overhead associated with these 4 aspects of a database that needs to be ACID. ACID is a big part of where you run into this overhead. And by going into Shore and actually modifying it to make it not need buffer management to run in memory, they found that Shore could run 35% faster. And they took out the need to log, it ran 17% faster. If they took out the latching and locking aspects, they got the 19 and 21. And when you subtract all those percentages, you find that the useful work in that database is about 7% of available capacity of the server to get work done. So they took a step back and said, okay, if we wanted to maintain SQL and maintain ACID and be more performant, we need to eliminate this overhead. How can we eliminate this overhead and still maintain ACID? First thing they did was they decided to eliminate the need to log, yet still be durable. They'd implement something called K-safety. Now, the smallest VoltDB cluster that's going to run is going to be 2 nodes. Durability is achieved by the fact that when you issue a transaction to the first node, it's actually also proxied to the second node and executed in both places. So our K-safety, our durability story is that you've got redundant copies of your data on multiple servers. Nothing is on disk, it's still in memory, but the transactions are executing at both, committing at both, before the user's given a response that the commit was successful.
They didn't call it like 50% of useful work. Because now only half, you have twice resources than you need, so it's 50%.
Absolutely, sure. And I'll show you where that can actually, depending on your workload, if you read, to take that the other way, if you're read intensive, I now have 2 places where I can do your read from. So I can increase some transactions get better, but absolutely. And sometimes, when benchmarks are benchmarks, and you can benchmark it to look better or benchmark it to look worse. Also remember that K is a factor that you determine when you bring up your cluster. So the cluster I just showed you is K1, 2 nodes, 2 copies of your data. You could have K equals 2, which means you have 3 copies of your data. You could have a 3-node cluster with 3 copies of everything. You could have a 12-node cluster with 3 copies of everything. So it's just a factor, depending on your use case and your potential concern about not having disk-based logs. Some of our customers, K equal 1 is they're fine with. Some of our customers want 2. If they're financial, they might want 3. Just a factor, you determine how high you want it to go. But that's how we eliminate logging in Volt. To eliminate buffer management, VoltDB is an in-memory database, period. You could boot it from a flash drive. It doesn't need disk, doesn't want disk, doesn't care about disk. There's some things we do that require disk, snapshots, for example. But booting up a Volt server, when I call Dell to order more service for my rack, they don't understand what I'm trying to accomplish because I get a single 80 gig SATA disk, and I get as much CPU and as much memory as I can possibly afford. And whenever I call them, they're always wondering what I'm doing with these servers because they're used to selling servers with 6-drive RAID arrays and SaaS 15K drives, and we just put these tiny little SATA disks in our servers.
So you have only buffer, and therefore you don't need to manage it because you don't need to figure out what goes in it and what doesn't go in it.
Exactly. The other thing we don't have to worry about in that vein is we don't have to have a data structure in memory that looks similar to a data structure on disk. So, and I'm just going to speak from an Oracle perspective. If MySQL is different or it's similar, certainly correct me or just nod your heads. In Oracle, as a DBA, I had to come up with a page size. Is it 16K? Is it 8K? Is it 4K? So then your data is arranged in these 4K pages, and then when rows go in there, you have some wasted space before and after. You delete a row. All that is gone in Volt in that not only is there no buffer, we don't have to worry about eventually putting the data on disk. And then to eliminate latching and locking, this is an interesting design decision. These partitions, which we'll talk about in a minute in Volt, when a transaction's running in Volt, it's operating single-threaded. There's no latching and locking. So as a transaction enters the system and runs inside one of these Volt partitions, that transaction begins and ends on its own. There's no other transaction going on within that partition at the same time. So there's no need to worry about locking. There's no need to worry about dirty reads. A lot of the stuff that you end up with in a traditional database where you have concurrency and concurrent access to the data. Because of that, these transactions, they operate extremely quick because there's no blocking. There's no waiting going on as the transaction runs. There's some downsides to that methodology as well, which we'll talk about when we get to the second part of the presentation. And then in a Volt cluster, this partition I'm talking about, it's similar to a shard. You put multiple partitions on a server, you have multiple servers in a cluster. Because these transactions are operating autonomously, you're doing, if you've got n partitions, you're doing potentially n of these transactions simultaneously in your cluster. And then lastly, the other advantage we had was we're built to scale horizontally on commodity servers. We started coding in 2006, 2007. Every line of code has gone toward a clustered database. It wasn't, we have Oracle, and then they come up with RAC and try to, trying to build on top of very old code and very old ideas is sometimes difficult. When you start with a clean sheet of paper, you can kind of cut some corners and get right to the heart of the problem you're trying to solve.
But what if 2 transactions try to change the same record or something? How do you manage that?
They can't. Transactions in Volt they're globally ordered. So when a transaction enters the system, it gets a global transaction ID, and that transaction runs in that global order. So when you mentioned about you'll see a little bit more about transactions on the next page. There's 2 types of transactions, but when a transaction is what we call single partition, meaning it's just running in the confines of one partition, it begins and it ends, and its end is either commit or rollback, and then the next transaction begins. There's no ability for two transactions to be running at the same time.
So the second transaction blocks until the first one's done.
Yes. Waits. Blocks waits.
Sure.
Absolutely.
So just so clear up my mind, if I have a petabyte of data,
Mm-hmm.
then I need,
That's not a Volt use case, but absolutely.
Okay.
You need a petabyte of RAM.
actually, I need
Two.
You need two. Yeah,
two,
oh yeah.
two or
You
three
need
petabytes.
yeah, and
Okay, so I'll let you get there. And then if, then in part of the durability story, so let's scale it down to, what is the bulk case? Is it-
absolutely. When we looked at the market and did some research, we decided that a terabyte and below, for in our mind, is the OLTP target we're shooting for.
Okay.
That there's the vast majority of OLTP workloads is a terabyte, and what we also found was lots of potential customers who talked to us and said, no, we're over a terabyte. We look at them and we say, you've got a mixed workload.
Sure.
Yeah. So Volt, we spun out of Vertica. Vertica is a great analytics solution. We've got hooks to get you into Vertica or to get you somewhere else, but one of the examples we use is package tracking. If UPS used us, we track the package from shipment, and it hops through a distribution center, and it's on a truck. Someone signs. Once that package delivered, data's stale, get it out of Volt, bring it somewhere else.
So I get that. So you're back to, let's say, a half a terabyte is your sweet spot of,
Mhm.
you need a half a terabyte of RAM doubled for minimum durability.
Yes.
And then if you're worried about when one server goes down, you need at least a third one. Would that be a fair?
Absolutely.
To maintain redundancy, you had to begin with, and they're replicated, then one going down wouldn't impact you, because
It wouldn't impact you.
performance-wise, it might.
Depending how long it takes to get it back up.
Sure. And the other thing we look at too is when you think about failure in databases
Yep.
and just servers in general, 9 times out of 10, what's the
It's a
failure?
disk.
It's a disk.
Yep. I just wanted to get it clear in my mind.
Yeah, and it's an interesting problem too, because when I talk to customers and they want to size these servers, RAM is like diamonds. I mean, when you get a 32 gig DIMM, is like 5 times the cost of an 8 gig DIMM. You know, it's crazy. So lots of these customers, they have to go wider instead of higher just because of the cost of these servers. I just read on Anantech that the new Intel platform that's coming out early next year, the Sandy Bridge, is going to support 2 terabytes of main memory in one system. Nobody could afford it. But man, it'd be really cool to have a Volt cluster. The servers I build, they're 48 gigs, so they've got 6 DIMM slots. We put 8 gig DIMMs in there. They work well. You know, they're dual socket, so there's 3 memory channels per socket, and that's 48 gig. I think is really a sweet spot for server memory today. And it really depends on your data center. You know, do you want to pay Dell for servers? Do you want to pay for rack space? Do you want to pay for cooling? How many transactions per second do you need? That's the other thing we run into is you can make a really wide server because you need that much RAM, but before you know it, you've built a cluster that can do 6 million transactions per second, and your boss is going to look at you and say, "What are you doing? We only needed 50,000. You're doing 6 million." You know, it's like
planning for growth.
Yeah. Best case scenario. So we talked a little bit about partitions. So in Volt, the way we size a server is on a server we'll put 1 partition per physical CPU core, give or take. And the reason I say give or take is we need some CPU power for networking, both client-server and server-to-server. So we've got transactions coming in and out of the system, and we've got servers communicating. So normally when I build my POCs and I talk to customers, if they're buying a dual-socket quad-core server, they're going to put 6 of these partitions per server, and then they're going to have X servers in their cluster to run transactions. From a data perspective, there's 2 types of tables in Volt, and there's a 3rd type we'll talk about later, which isn't important for transactions. So the first type of table is partitioned. A partition table is a table where you're going to take the rows, it's just like you sharded a table. You're going to take the rows, and based on a hash algorithm, we're going to put a certain number of rows within each partition as they come into the system. The way we do that is you pick a single column in the partition table that serves as your partitioning key. We spread those rows across all the VoltDB partitions by column with a very simple modulus function. And this is going to be your transactional data. This is data that's got a high frequency of modification. Lots of inserts, lots of updates, lots of deletes, and lots of selects. So if you're doing an order entry system, this is going to be your customer order table, your inventory table, those types of tables. We also support a table type we call replicated. And in a replicated table, every single row in that table is going to exist in every single partition within Volt. This is your relatively static data that doesn't change that often. And back to your point about memory, because you're putting every row in every table, this guy actually counts against you.
Right.
If you have a very large replicated table, it's going to take up more memory than you think because every row has to be stored in every single partition.
This is typically dimensions in the star schema data.
City, country, yeah, simple lookup data that you need to have around. I've seen some use cases where it's a little different, but for the most part, it runs that way. So in Volt, we've got data and then we've got code. So for your code, we've got two types of transactions, of store procedures, and they're both ACID. The first is a single partition transaction, and it kind of falls the same way. You've partitioned your data into these partitions. Hopefully, for a good Volt use case, you're going to have lots and lots of this single partition work. And this is work where any insert, update, or delete operation that needs to be performed can be performed within a single partition. This needs to be the majority of your transactional workload. If your workload can't be partitioned, and your workload can't be broken up into this single partition work, you're not really a great Volt use case. You know, we could, the smallest Volt you could ever build is two servers, each with one partition. And in that case, everything is partitioned because it all hits that one partition. Everything is single partition. And I'll tell you, Volt can do about 80,000 transactions per second at that size, but that's it. There's no headroom. If your use case fell into that example, all you have to go on is Moore's Law. Faster CPUs and faster memory, and Volt keeps getting faster, but for the most part, you know, a good Volt use case is one that's going to scale by adding servers and adding partitions to servers. We also support multi-partition transactions, and this is CRUD against partition tables across multiple partitions. So if you had to update against rows cross-partition, we can do that in this type of transaction. It's also where you're going to insert, update, delete your cities, your states, your countries. This needs to be the minority of your transactional workload. What I really like, though, is that we accept that those aren't very performant, but we do them. So we don't leave it up to the developer to have to, if you want to insert a city, insert into all 24 partitions and commit into all 24 and hope everything went well. Volt will do that for you.
So now, does that work with things that don't relatively, like, do most people in reality use that for things like a user ID, where their user ID might not change, and their name and all that stuff that you look up all the time, as opposed to a city, which you might not only look up when they insert their address.
Yeah, and some of those customers will do users kind of an interesting example, but they'll do batch updates to stuff like that in a kind of a maintenance window where there's not high volume on the site, or they'll kind of funnel those transactions in, because the worst thing you could have happen is if you've got a workload where multi-partition, you're doing 20 of these per second, 20 multi-partition transactions. And in the course of a day, you might do 50,000 because you're doing 20 a second-ish. You never want to try to jam 200,000 of those into a 5-minute window, because that's going to really slow down the rest of your system while those are actually running. I pulled this slide in. I don't normally do this on my presentation, but I think in this room this is going to be extremely relevant and helpful to making sure we all understand single and multi. So in this example, a very simple one, let's not talk about durability and case safety. We've got 3 partitions on a server. Partitions 1, 2, and 3. And we've got 2 tables. So our first table is a table called orders, and it has 3 columns: customer ID, order ID, and product ID. The table down bottom is a replicated table called products. So as you can see, this has a product ID and a product name. So knife, spoon, and fork, because it's replicated, all 3 rows are in all 3 partitions. The order table, it's partitioned on customer ID, and it's a very simple modulus function, so let's just make it dead simple. So when customer ID is 1, we're going to fall in partition 1. Customer ID 2, partition 2, 3 goes to 3, and then 4 moduluses back over to partition 1. So the rows fall in here 1, 2, 3, 4, 5, 6, 7, 8, 9. As you're putting rows in this table, that's how the rows are going to land in these partitions. Where that becomes relevant to transactions is just think about SQL, because SQL is really what determines how Volt can do certain operations, either in a performant way or a less performant way. So this first example is a single partition. If this was all a store procedure we're doing, this would be a single partition store procedure. I'm asking Volt to give me the count star from the order table where customer ID equals 5. And because in my my query there, in my where, I've got customer IDs in my where, Volt knows that when customer ID equals 5, that all rows for that SQL have to exist in partition 2. There's no way they could be anywhere else. 5 maps down to partition 2. I can also select against this table in a multi-partition way. So here I've said, give me count star from the order table, but instead of saying where customer ID, I'm asking where product ID equals 3. So in this scenario, Volt has to go to all 3 partitions, look through the rows, and it found 1 row here, and no rows in partition 3.
For that one it locks all.
What's that?
And for that one it locks
Absolutely. In a multi-partition transaction, it's not this nice little autonomous, everyone's running simultaneously. Everyone kind of has to block while the operation occurs. And they don't, reads and writes, I mean, there's lots of optimizations behind the scenes, but at its simplest form, you can just think that in this scenario, I have 3 partitions. So in a given unit of time, I can do 3 single partition transactions or 1 multi-partition transaction. That's the easiest way to think about it. There's optimizations in the code right now and optimizations going forward that'll make that better, and like cheating and going ahead and all kinds of fun stuff. But for now, it's easier to get your mind around it to just think of it in those terms. As you can see here, those were select operations, but in the same way, when I'm inserting a row, again, into the order table, I know the customer ID. I know my value is 3 for the customer ID, so I know that has to go down to partition 3. Again, single partition. And then not to be left out, multi-partition work. I'm going to update my product table. I'm going to set the product name equals spork, where product ID equals 3. It's a replicated table, so that SQL would operate at all, execute at all partitions simultaneously. So we've talked a lot about a partition. Let's take a kind of a closer look into what does a partition actually look like in a server. So inside your server, the partition contains 2 things. It's got data, it's got space for data in it, and what we're calling an execution engine. An execution engine only knows how to execute SQL statements. As the note down here says, in the table and index data, we keep a complete copy of replicated tables and a portion of the rows of any partition tables in our system. Sitting on top of that execution engine is a queue for these transaction requests. Your comment earlier about 2 things running simultaneously. As transactions enter the system, they're uniquely stamped, and they all end up serialized, and they end up landing on top of these partitions, the correct partition. And then this execution engine, it runs these stored procedures to completion, sequentially, single-threaded, commit a rollback, move on to the next transaction.
That's not 80,000 transactions a second, be careful.
What's that?
That was a joke. Never mind.
That's
It's
not.
scrolling so fast that,
Yeah.
Each one is in the
So is that why you have 1 partition per physical CPU? Because you can't really use more than 1 CPU in a query, so you might as well.
1 per core.
1 per, you said physical CPU, I thought.
No, core, 1 core, yeah.
Oh, physical CPU core.
Yeah.
Sorry, that's what I wrote down.
Yeah, right there.
Sorry.
They map threads to the cores.
Yeah.
Yeah.
Yeah. So my point about Moore's law and the smallest volt, it also goes to, at the end of this year, Intel's releasing a new chipset that'll do 4 memory channels per socket. Right now we're bound by 3 on the Helm servers, and all that stuff. Some of my numbers will start to go up. In our TPCC implementation, we actually do 12 partitions per server. So really, I do tons of benchmarking with Volt. My sweet spot is normally 6 partitions on a server, but if a client's use case is a certain way, if their transactions are smaller or larger, you might want to put more on there. Hyperthreading sometimes. Hyperthreading seems to help TPCC for some reason with Volt. But it's kind of you build a POC, you do a lot of benchmarking, and then you decide what works best for that particular use case. So compiling, how do you actually get a Volt app up and running? Create a schema file. Regular, standard looking DDL. Your create tables are in here, your create indexes, and Volt supports materialized views for sum and count operations. Create a handful of these stored procedures, which is your workload. And then we have a project file. This is going to contain users, passwords if you're going to secure your application with passwords, user groups, and it's also where you define your partitioning rules for your tables that are partitioned. We decided to keep that out of the DDL, so the DDL would be a little more standard as opposed to trying to mark it up with some Voltisms. That collective set of files gets run through the Volt compiler, which creates an application catalog. The application catalog is a Java jar file. It's going to have your all the execution plans for the SQL within the stored procedures. It's going to have all your security and your schema. You know, one thing I don't miss about Oracle is installing it on a new server. One thing I like about Volt, your application catalog plus a single jar for Volt and a shared library that's Volt's execution engine. It's a 3-file install onto your servers. Of course, you know, they have to have Java there already. The JDK needs to be present. But it's a very, very easy install to get running on clusters of servers without having to do a lot of, you know, I just think back to Oracle when I'd watch shit put 15,000 HTML files on a server, even though I didn't want documentation. It just insisted on kind of doing its own thing.
So any improvement on GRE for you is very important.
What's that?
Any improvement on GRE for you is very important.
Yes, and we've found, given the rate at which we do certain things, we've found defects and we reported them, and they've made it to the official Sun one. One of our fixes actually finally made it to the OpenJDK version. So we're very specific. If you're going to, on your servers, you need to run Java 1.6, update 18 or above. And there's one also optimization they made in update 18 that you have to turn off when you're running Volt, because it's a garbage collection improvement that's actually defective, so it breaks Volt as well. But yes, we're very, very particular about the GRE. And then you start your servers, and in this example, you'd have a running 5-node Volt cluster. Since we just built the catalog, it would be empty. There'd be no data in there, but Volt would be up and responding to requests at that point. I'll blow through this transaction slide because this is a lot of the details I'm going to get into in the what's it like to work with VoltDB. But just high level, access to VoltDB is via Java stored procedures. They're Java interspersed with standard SQL. When you invoke a stored procedure in Volt, that is a transaction in and of itself. There is commits on success, it rolls back on failure. There is no client-side control of transactions with Volt. Certainly, this significantly limits the round trips between the database servers and your client applications. And something we'll get into in more detail is you can write a really high-performance client with Volt because our wire protocol allows you to communicate asynchronously with the database. You're not synchronously putting a transaction on the wire and watching a response come back. You're putting as many transactions on that wire as fast as you can, and then you're actually pulling responses off the server. Depending on how you're writing your application, in Java you do it in threads, in C++ we do it a little bit differently. But it's different, and you can wrap it so it can be synchronous for the people who want to be synchronous or like that lifestyle, as one of our developers likes to put it. But we just find that, you know, the kind of use cases we're looking at, to drive a very large cluster synchronously at the level we're driving it, we just require far too many client machines. So we tend to be doing all our stuff asynchronously.
If you run Java, why you are limited by Linux? You actually can run Java on other machines as well.
Java would be fine. Notice I said there's a shared library. So we use C++ for all the execution engine. So all the actual access to data. Lots of C in there, lots of C++. Yeah.
That was my another question. Yeah.
So you can write we have a Java client library for client applications, and you can run that. You can write a Java client, run it on Windows. We don't support it. A couple people in the community said it works just fine. We're a little nervous about it, but yeah, the port would be dealing with the C++ side. Just to speak a little bit about scalability and durability. For scale, certainly if you've got a set of servers and they're performing the transactional workload, you just need more memory. You can increase the RAM in your servers, make your cluster larger. You can add servers, which will both increase performance as well as capacity. And then lastly, I consistently, our yardstick is 90%. Normally, if you write an application in Volt and it does about 100,000 transactions on one node, each additional node beyond the first will add about 90,000 transactions per second. So if you're doing 100,000 with 1, 190 with 2, 280 with 3, 370 with 4. We've taken this, we've got some results coming out soon. We've taken it up to a 30-node cluster, and at the 30-node level, I think we were slightly over 90%, it was like 91%. We certainly see at some point, the bottleneck is going to start being the communication between servers. So the network that's actually meshing these servers together, when I send in a transaction and I'm case safe, so that transaction has to execute here and here, it has to be passed between the servers. Everything we've done to date has been on a single switch, both client and server traffic all sharing this. So down the road, if someone builds a massive cluster, we're predicting either A, we're going to need 10 gig equipment, or B, we're going to need a front channel for client-server communication, a back channel for server-server, maybe bonding some network cards. You know, there's many ways to handle that problem. We just haven't created a cluster large enough to see where the problem starts occurring. But at the 30-node level, the transactional throughput is, you know, over 3 million per second. So it's kind of hard for us to imagine right now someone who's going to run into that. You know.
Have you played with with nodes that aren't the same? You know, so you have, you know, because this is something I'm envisioning you just throw any old hardware at because it's kind of a per CPU and RAM kind of thing.
You can. I wouldn't recommend it in production. Certainly in test, it wouldn't be a bad idea. A couple things are going to happen. One is you might have faster or slower CPUs. You might have more or less actual CPU cores. RAM sizing is important. You know, you want a nice, somewhat even distribution of data, and you want your servers to have something of an even distribution of RAM. But if you were to put faster servers alongside slower ones, as we mentioned on the multi-partition work, you're going to kind of be waiting for that last guy to come along. Right. So my assumption is it will drag your cluster down. I haven't measured how much. Everyone we've talked to is either has the similar equipment, or when they're ordering, they're calling Dell and saying, "Give me 12 of these." Not a kind of mixed rack. But it'd be interesting to see what the results look like.
Well, because eventually it becomes mixed, right? You know, no matter how you start, it eventually becomes mixed. So you have to upgrade and.
Oh yeah.
And all
I mean, hopefully mixed is I ordered 12, and then a year from now I ordered 5 more. Not I started with 12 from 3 years ago. I've done some on sites with customers, and I, you know, I want to talk the great things about Volt and the not so great things about Volt. Volt on Nehalem, which is the Xeon 5500s. If you call Dell right now, they're going to sell you a 5600 series Nehalem. If you called them in the last year and a half, you probably bought 5500s. And if you called them before that, it was 54 and whatever came before 54. Like dual core, maybe single core, hyper-threaded. Volt runs fantastic on Nehalem. Absolutely. 3-channel DDR3, QPI between the sockets. Everything runs great. On earlier equipment, Volt, it's still very, very performant. But if I show a user a number on a 5400 and a 5500, it's night and day, the level of performance between those two servers. So the other problem is, if I'm going into a shop and they're dragging this stuff out and blowing the dust off the top, and I did some benchmarks back in the shop, and I show up down there and I'm like, well, I was getting 75,000 per node, and then we run the test on their equipment, they're getting 15,000. Then it's normally when we go into their server room and we swipe and look at, oh, we're running on a desktop or something to that effect. Availability, we talked a little bit about. Case safety for redundancy. We keep K+1 copies of your data in the cluster.
You mentioned, I think twice, that the sharding is just simple modal distribution. Any plans to?
Absolutely, yeah. So for integer types, you can shard on partition in the Volt term. If you partition on integer types, it's a modulus function, just rolls. If you partition on a varchar, on a string type, it's an MD5 hash, some hash type, and then a modulus on that to map it back. On our roadmap is eventually is user-definable partitioning strategies. And the interesting part is, if we're dealing with someone who's doing a stock trading application, certainly like Google and Apple dominate a day's trades. And I can speak to a use case that I talked to, and even a user-definable hash wouldn't have fixed it, but I talked to a gaming company and they wanted us to do a leaderboard application. Did the POC, showed them amazing numbers. I had a random user generator that would submit scores, and it was doing just fine, amazingly fast data. Then they gave me their log file of the actual submissions, and it was a pretty popular gaming site. And they never told me in the beginning of this that 75% of all submissions to the leaderboard are one game. And the next 20% are game 2, and the last 5% are 400,000 games. and so think about it from a Volt perspective. That's probably a 2-partition server. Because if I go 3 partitions or 500 partitions, it's not going to make any difference at all. 75% is going to hit one partition, 20% is going to hit the second one, and that other 400,000 are going to be spread amongst the 3.
There's no other key you can split them.
There was nothing else we could do for this leaderboard app. But you know, we're open source. If you grab our source tonight or tomorrow and you looked at our hash function, there's a function right there. So right now you could take it, you could change that hash function to your own, for your own needs, compilable, have at it.
And the follow-up...
The challenge would be, it would be like, I think the best case partitioning strategy is that we let you do it at the table level. You know, for this table, partition and range, do it this way. For this table, use the, you know, default function and so on and so forth.
And the follow-up question about charting isn't just adding a new one, but redistributing the old ones. Any thoughts about that?
That's on the roadmap as well. You know, you could see on the downside to sharding, I knocked sharding as shut it down, bring it. That's Volt right now. Right now, if you want to repartition, you're coming down and you're coming back up. I think because of some of our design decisions, I think we're going to be able to do that faster and better than other people. But it's not something that if you grab Volt right now, it's not in the code base. So snapshots. This is the only reason right now to have disks in your Volt servers. So while Volt is running, as a system administrator, you can schedule snapshots to run to disk, and these can be one time, they can be continuous. And what the servers are actually doing is they are collectively deciding at what point in time to begin the snapshot across the entire cluster, and everybody's backing their own partitions up to their own local disks. The way it's actually pulled off is we do a copy on write. So as we begin the snapshot, we start writing data to disk. If a transaction, we're still processing transactions, so if a transaction comes along and it is attempting to modify data, we make a copy of the before image, and we let it modify data in place, and we have buffers to keep these copied tuples out of the stream of the actual transactions that are running. I've done a lot of benchmarking, a lot of testing on this. Live running snapshots produce about a 5% drag on your server. So as long as your server, your cluster is properly sized and you've got additional capacity, if you've got everything pegged at 100%, snapshots are going to really affect your performance in a noticeable way. If you're running 50, 60, 70% of CPU, the difference on your performance is going to be marginal. You've got additional CPU to get this done. And then the last thing we do is we support spooling to a data warehouse. You talked about a petabyte problem. You know, we certainly see we're playing in the OLTP space. We want to be focused on OLTP problems. We're not OLAP. So in Volt, we have a concept of a table that we call export, or export only. And these tables are special in that in an export only table, all you can do in your store procedures is insert into them. You can never select update or delete. A plain old export table, you can do all these operations. What happens in the background is as these inserts or insert updates and deletes occur, we actually take that data and buffer it, and then you can have a special client application come along and actually pull data out of Volt. So in the package tracking example, when you ship your package, it's a transaction into Volt to create the package to be tracked. It hits a distribution center, there's a transaction to update the status and maybe add a row. When the package gets delivered in that transaction, you'd actually take the history of the package and dump those rows into an export-only table. That commits the data has now come out of the real table, it's in the export-only table, and then we've got a connector where a client app can come along and pull it away. Right now our connector supports, it's just spooling to the file system, so you'd have to write something to troll that and pull the data in. On the roadmap is JDBC, so we could have a client connector that would pull from Volt and push into any JDBC compliant data sources. And then lastly, again, this is a feature that's not in Volt right now. For disaster recovery and WAN replication, we're going to support asynchronously. What we're going to do is be shipping and replaying the committed transactions across the wire to another Volt cluster in a different data center. The lag, you know, how far behind this falls is really going to be dependent on how many transactions you're processing and how thick your pipe is between the two sites.
The current disaster recovery to-memory system, one goes down, what happens when it comes back up again?
We call that a failed node recovery. So in the shipping version right now is 1.1. The only way to bring back a failed node, disconnect your clients, take a backup, bring your cluster down, bring your cluster up, reload. 1.2, which is due end of September, early October, we're going to support the ability to bring a node back online while the cluster's running, while transactions are being processed. So it's similar, you know, to a lot of these other, you know, reading up on NoSQL solutions, they've already got that. It's, you know, they might have a different name for it, but certainly the ability, something dies, it's nice to be able to rejoin and get back to work without having to bring everything down and bring it back up.
I mean, it's the equivalent of adding a node, it's the same thing, it seems. It's like, I mean, it was there before, but now it's gone. But
Yes, it's actually easier than adding a completely new node because we don't have to repartition, right? All you're doing is taking the place of the old guy. It turned out to be a little messier. You know, a lot of the devil in the details and some of this functionality is just the what ifs. If there's a failure while something is recovering and how that scenario plays out. So I think when I listen to the developers talk about getting some of these features done, it's much more time is spent on the edge cases that are the really bad things that can happen as opposed to optimistically just rejoin a node in this cluster.
One more question, if you go back, what do you mean by continuous snapshot? I mean, I do understand the scheduling.
Okay, so snapshot, you can schedule it. You can say do a snapshot tomorrow at 8 a.m. You can do it on demand. You can say run it right now. Or continuous, you can say run a snapshot every, you pick every X seconds, minutes, hours, days. So you could go in, when you bring your cluster up, you could say I want a snapshot every minute, and I want to save 5 snapshots. So every minute Volt initiates a snapshot. If it finishes it before the minute's done, it'll wait that X seconds to get the next one going. And when it starts up the next one, it's going to look and say, oh, there's already 5 here. You only want to save 5. I'm going to kill the 5th one and start a new one. So the continuous is going to be if you set that frequency faster than it can actually get one done, then as soon as, if you said run it every second and it takes a minute, then as soon as that minute's done, it's going to start the next one. And you'll, so you know, in terms of being durable, these snapshots are consistent. There's you can recover from that and not have to worry about inconsistent data. But the downside is it's that, you know, the window between snapshots is your potential for data loss. You know, not having, if you're case safe, you're not going to have data loss. But if your entire cluster goes down and we don't yet have this WAN replication, then there's no way to get those transactions offsite to somewhere else.
Is there a way to fake logging by doing a stored procedure that says log the statement kind of thing?
You could fake logging by in your client app. You could have your client app log.
Right.
Your stored procedure. Absolutely. You know, we're at the time. I didn't talk about the company. We're 15 people, 14 people,
Right.
5 core developers. So very, very small, very, very intimate company at this point. You know, I got approached by one of the Java developers the other day, and he said, "Hey, what would you think if I could do a write-ahead log?" I'm like, "Why not?" I said, "Well, as long as you can do something with it. Like, don't do a write-ahead log if I can't like play it back." But he's got some ideas on how we can do a write-ahead log and not have it impact performance.
Yeah, we use logging logs a lot for forensic to say, hey, how come this changed? When did it change?
Mm-hmm.
You know what I mean? So it has nothing to do with actual, you know, let's say MySQL, you need logging for replication and all that kind of stuff, you know, or point-in-time recovery. You know, we don't, the most that I've seen it used, which you can't really get in any other way, you know, at least if you wanted a point-in-time, you know, replication, you wanted a backup of something, if you didn't have logs, you could at least take a backup of the current one and say, okay, now take the backup.
Yep.
But you can't really get the forensics of what happened when.
Yeah,
So.
and the EL, the exporting functionality, you can kind of twist into doing certain things like that. The trick becomes, I might be talking to a customer who wants to do 1 million transactions per second, and then there's customers that are like, that operate in the real world and they want to do 6,000. You know, certainly 6,000 is a much easier problem to solve than 1 million, and do logging and, you know, X, Y, and Z.
Right.
So how do you, when you start this thing up, do you have to load it with data? I mean, if you want to be able to select against it, I mean, like the memory DB type in MySQL, you have to load it from existing tables to get it started.
Yeah, so when I showed this, you know, where you take your DDL, you take your stored procedures, you take your project file, you compile it, you have a jar, put it on the servers, bring it up, it's empty. There's not a single row and a single table. So if what you're doing is, if you've modified your schema slightly, you can reload a snapshot, and it will handle the schema changes for you and reload that existing data. If you're starting from ground zero, then you're going to have some simple client applications that load the city table, the state table, the customer table. You're going to, hopefully you're coming from an existing system,
so this
which you're exporting from.
So this software, the Java app and its SO persists the data, the snapshots. That writes them to disk.
Snapshots get written to the local disk on the Volt servers, yes.
Okay.
So if you have like a server restart, the whole server restarts, there's a power failure. Then it comes back up and looks at the snapshot basically?
It's not automated right now. So if your server rebooted and you had to restore from snapshots, then you would be scripting the restore from a snapshot.
Okay.
But hopefully,
you
if you had a cluster,
you can't just say start VoltDB and it'll look at the thing. You have to manually. Okay.
no. And we're building management tools right now. That's another thing. But to your point, hopefully, one server rebooted and you still had.
Your KSAP, yeah.
Yeah, I mean, there's case safety in numbers, I guess. Is a good way to put it.
So when another server comes up, it has a copy, it has to populate that in server that rebooted.
Yep.
And while it's rebuilding, how aware of it? Well, like in the case of RAID, if you lose your one of your parity disks, then you go into degraded mode. And then, of course, when you rebuild, you go into a further degraded mode.
Mm-hmm.
Does the software, when it's rebuilding, go balls out to rebuild the new node? Does it have a take it easy sort of thing approach, or
the implementation we're doing for the end of this month is going to block the partitions that are recovering while they're recovering are going to block. So it's going to use your word, balls out as quickly as possible to rebuild each partition, server to server. Get that done as quickly as possible. Because the initial implementation is that way. The longer term is going to be to get that window as small as possible. But our first implementation about letting you do a rebuild online without having to do a dump, shut down, bring up, restore everything, that's the first implementation. So yeah, it's going to give it everything it has. It's going to take as much of that network bandwidth between servers as you have available, and as much CPU power on the recovery side as possible to get those transactions done.
on a 500 gig database, how long do you think that'll take? Or on a 100 gig database?
Well, it's how much memory is in any one given node. If you only have 48 gig in a node.
Our goal is a 2-minute recovery.
Okay.
And the problem with saying that, that's in a room when you've got sales and marketing and the president and the VP of engineering. And what does 2 minutes mean? Well, is it fair to say 2 minutes if it's a terabyte? Probably not.
Are these Earth minutes or Mars minutes or like Mercury minutes or Pluto minutes?
Earth minutes. Yeah, and hopefully it's never worse than that. Hopefully it's always faster. But if you've got a half TB, it's really the per server memory that matters. I just got my first cut of that code last week. Ran some tests. I didn't like the performance. I sent it back to the developer. He's optimized. He's done some stuff, so I put it out to the community. But he has other enhancements to do. And it's like any other database. When that data is plowing back in, we're rebuilding indexes. If you've got materialized views, we're rebuilding those materialized views and indexes on those views. So certainly the first blush when he gave me the code, his initial testing was on like a simple table with no indexes. So it went really fast. And then I had indexes and views, and I said, Ariel.
Now I can hear him say, just going, dude.
Pass my test.
If you're all in memory, why do you need indices?
Why do we need indices?
In memory.
Just for direct access to.
Still faster than a full table scan.
Yeah, I mean we've got hash indexes and tree indexes based on what you're trying to do. If you've got exact equality in your where, your index lookup is going to be 2 hops through memory. When we talk about the
So it's for covering indexes, basically, right? For covering.
we have tree indexes if you're doing range type queries, and we've got hash if you're doing direct equality.
But the degradation relative to disk might be sufferable without index recovery, wouldn't it?
It might, and one of the points I went back to the developer with when he profiled a lot of the code to find out where the time was going on recovery. And I said, I'm not the internal Volt guy, I'm the guy using the app, but I know Oracle 101 as a DBA, I would use SQL Loader and I would load, import export. I'd use import on a table and then I would add an index. I would never have the index there while I was loading my data. It just made sense, and I don't know if, I just put that out there to those guys, they're kind of gnawing on that, because I'm sure what they have right now is just using the exact code path they have for everything, and why not just keep reusing that code?
Well, memory operations are I/O operations. In any case, they're just faster I/O operations.
Yeah.
So.
Coming back to your recovery, so if the whole site loses power, all your nodes are down, at that point of time, what is your recovery? Are you recovering from the snapshot, or what does Vault do?
We support 2 types of recovery. So one type of recovery would be you want to recover from snapshots. If you're recovering from snapshots, you're recovering your entire cluster. You're not just going to recover a single node in a running cluster, because if your cluster's running, there's an online recovery where you can Not in the product as you grab the product right now, you're not going to have it in 1.1. 1.2, it's end of this month. If a node fails, you can rejoin a node to take the place of that node. It could be the same node, it could be the node's brother, someone across the other side of the data center, it doesn't matter. As long as you've got a node that's got enough memory and enough CPU power to handle it, you bring Volt up on that last node, and you say, I want to do a recovery, and my cluster's over there. And then Volt looks at you and says, A, did anyone fail that you're replacing? Because you can't replace someone who hasn't failed. Yes, okay. B, here's the partitions you have to recover, let's get going. And Volt handles transmitting the data from the living side of the cluster to this newly rejoined node. If you're recovering from snapshots, it's just like in my Oracle days doing an export-import or SQL loader. It's everything's there. I'm bringing up an empty cluster and I'm
loading. Let me rephrase the question. Forgetting snapshots. If the whole data center loses power, all your nodes are down.
Okay.
In that scenario, what are you doing? Are you reloading the database?
In that scenario, if that's a possibility, which it probably is for anyone, you want to be taking those snapshots at some regular interval and getting them out of that power grid site, whatever you want to call it. Because right now, as you can see on the bottom slide there, we don't support, you can't build a cluster in the current product. DR recovery, that WAN replication, that's meant for, I've got a cluster in Somerville, and I've got a cluster on the West Coast, and my main cluster's in Somerville, and as transactions finish, I'm going to ship the completed transactions over here asynchronously. And this guy's going to be slightly behind, but seconds, maybe a minute, who knows. But you can't do that with the current Volt. You can't put half your cluster in Somerville and half in California, because if you did, it would be incredibly slow. So back to your point, in that scenario, you want to be snapshotting, and you want to have a process around your snapshotting that compresses those snapshots and FTPs them, SCPs them, however you, in your normal operations, would get data out of your data center. You want to apply that to the snapshots.
Right. I mean, that's still assuming that your primary site went down and it doesn't come back up.
Mm-hmm.
All I'm talking about is sometimes you get this power fluctuation where the power just goes down by 5 minutes, but all your servers are down. You get the power back. Can you still bring up the database?
You can recover right from the snapshots. Yes.
Okay.
Yep. So all the snapshots are is each, since it's a cluster, each server snapshots to its local disk, its own partitions, just to be as performant as possible. And it runs very, very quick. Even on those single SATA disks that we use, we get about 60 or 70 megabytes per hour. We get a really good number.
So taking snapshots is critical to come back at that point, right?
Absolutely. Yeah.
Unless you want to reload your entire database back into Volt.
Well, that's the question. Can you do that? But at that point of time, I could have lost transactions, right? If you lose power.
Yep.
That's why you have a UPS in your data center, and I mean, I've got a UPS on my laptop at home.
Well, your laptop's got a battery, it's almost
Yeah.
like a UPS.
I've got it plugged into a UPS anyhow.
Now I said that was only
sort of an operation there.
Yeah.
I said that was only going to take 10 or 15 minutes. We went a little longer, but hopefully it was interesting. This was the part for me though, because I do that. Those slides I do every other day of my life. This was kind of fun for me to just put together a mishmash of, what was the first 18 years of my career like, and what is my last year of my life been like. So what was it like working on Oracle versus what is it like working with Volt? And again, at the bottom here, I say in no particular order because I was just brain dumping and coming up with new ideas and trying to put as much good stuff in here as possible. As we spoke about in the other slide, this blew my mind when I started at Volt. Writing client applications that communicate asynchronously with the database. It just was really, when I first started thinking about that and what that meant to me, it was hard to get my head around. But what it means to an app developer, we've got a documented, pretty straightforward and simple wire protocol. So you're issuing store procedures to Volt, and you're putting them on the wire. So you've got you want to get a person's salary, and you're going to issue a get salary store procedure with a employee ID. You put that up on the wire, and then some point in the future, the server has fulfilled that request, and it's got sort of like a mailbox on it that has the response for your transaction. So you write these Java store procedures. They can return a single value. They can return an array. They can return an array of arrays. So pretty much anything you could do in SQL for return values, you can do in Volt. But in this way, you're putting these transactions on the wire, and then you've got another thread in your client application that's pulling the responses back.
But that's how usual internet applications now work. they don't communicate with the database directly. Instead, they communicate with the application servers, and that way asynchronous communication happens. You call JBoss and you forget about that. It goes into the database, but not synchronously.
I put a little sample code at the bottom, which I think points it out better. One thing to note here, though, is look at bullet 3. Because we're working asynchronously, if we work synchronously with Volt, and Volt had a latency of a millisecond, then a client app can only do about 1,000 calls per second. And maybe you fan it out and you do some threading or you do some connection pooling, but you're still going to really be gated by some really low numbers. In Volt, when you go asynchronous, you can do well over 100,000 of these stored procedures per second from a single client. And the last bullet here is if you like synchronous, our client library will simulate that for you. So we'll actually wrap the asynchronous in something that looks synchronous to you. So in your code, you can call a stored procedure, and the very next line of code, you can have the response. This is PL/SQL, so hopefully it's close enough to MySQL procedural language. But as I have here, in a traditional
MySQL procedural language is just SQL, so
MySQL doesn't have stored procedures.
they have stored procedures in SQL. You can write them in SQL.
But there's no procedural language within it.
Yeah, there's some basic case and if, but I think we all kind of know procedures enough, programming languages enough to know that. But
Okay.
Oracle
for you to
invented
know
their
and
own
laugh
another language just for stored procedures,
Okay.
and MySQL couldn't afford that.
Well, you
Well,
have
they can now that Larry owns
UVMs,
it.
yeah. Well,
So in PL/SQL, if I wanted to get someone's salary and I had a stored procedure called get salary, I would say salary takes on the value, get salary, paren, employee ID. In Volt, this is what it would look like in Java. I'm going to do a call procedure. The first thing I'm going to pass to this procedure invocation is a callback, because as I said, this procedure is going to go on the wire, and then my client library, some point down the road, is going to pull the response back. When the response comes back, that callback there is a function in my client application that's going to get the result from that stored procedure. It's a little complicated until you look at a whole program, but just trust me, it works, and it's really not that bad once you look at some sample code. But same thing, I've got a stored procedure called get salary, and I'm going to pass a parameter employee ID in the call. Because we're asynchronous, that really leads to this bullet, transactional control. There is no client-side transaction control in Volt. And again, this was another thing that took me a while to get my head around when I started using Volt coming from an Oracle world. So as that first bullet says, you cannot do insert into T colors, color name, values, purple, and then roll back. If that was your client-side application, that first thing would be in a stored procedure, and there is no rollback. When that stored procedure finishes, that row is in the table. If for any reason that inserting that row failed, it rolled back whatever else was in that stored procedure and comes back to your callback with a failure. But either way, you put the transaction on the wire, and it's like auto commit on steroids with Oracle, where it's all server side at that point. Server's deciding whether or not things are.
it's like using a MySQL table. There's no rollback.
I realize that OLTP is different than OLAP, and it's usually just as straightforward as that. But sometimes it's a little bit more complex.
Mm-hmm.
So you're turning client transaction coders into server coders.
Yeah, in a way. I mean, personally coming from an Oracle world, that's the one part of Volt I was very comfortable with is stored procedures, and talking to lots of Microsoft SQL Server type people, doing a lot of stuff in stored procedures made sense, and people were used to it. But yes, absolutely. The PHP application developers aren't always so happy when they look at something like this. And as you can imagine, we don't support ORMs very well. Like Ruby on Rails is kind of not a direct port to get rolling with Volt. So as you can see, the store procedure itself, when it goes over the wire and hits the server, it commits if it's successful. It rolls back if there's an internal server failure, like a constraint violation or something. But also inside your store procedure, you can have client code that can detect a rollback condition that's really application dependent. So if you find someone's trying to take money out of their bank account and they're bringing their balance below 0, you can call for a rollback within your store procedure, and it gets rolled back just as if there was a constraint violation or something else that occurred. So interfacing with Volt. Client apps interface with Volt via stored procedures only. You write Java stored procedures, they're Java and SQL. That's it. There's no ODBC, there's no JDBC.
What does mean Java and SQL? Means how SQL coexist with Java?
So we have your SQL is interspersed. So you'll at the top of your classes for your stored procedures, you'll actually define the SQL. So you've got insert statements, update statements. They're parameterized, so you can pass variables, but you can't dynamically build SQL in the stored procedure. So if you had a stored procedure that was going to test their account balance and then do a withdrawal, you might have a single SQL statement in there to select the balance, and then a second SQL statement in there to decrease the balance and insert an audit record.
So you essentially use strings. You put SQL statements in the string into strings.
Yes.
And provide it to the subroutines or to the methods, something like that.
Yeah, and I can probably pull one up quick enough.
Okay.
I'll just pull up a stored procedure real quick. So I have an application. I'm still uncomfortable with my Mac, I'm sorry. I use Linux all day, and Mac and Linux are still different than I'm used to. So here's a Volt stored procedure, an application I built called Voter, which simulates American Idol voting contest. So a stored procedure called Vote, it takes three things. So when you call the stored procedure, you tell it who's voting, what's the voter's phone number, right there. What contestant number are they voting for? And for this election, how many votes per phone number are allowed? And as you can see here above that, this is where my SQL is. So I've got, yeah, my Mac's gonna get a little crazy when I try to
Yeah.
So my select statement, my insert statement, it's all just SQL right within Java.
Right. It's not. If you remove from JDBC those update or some other prefixes, it will be similar to that.
Yes,
Yeah.
but absolutely. And I mean, the other difference is when I'm firing off this SQL, I've got a full Java language to do conditional logic, check the results, do
nice.
this, do that, lots of fun stuff. But remember, while this stored procedure is executing, everyone else is waiting. So as a slide comes up, don't send an email from your stored procedure.
Yeah.
Don't call, don't get a quote off the web. Things like that would be really bad use cases. But you can do it. We're not going to stop you. It's
Right, and sometimes it might make sense.
yeah, depending on your app.
Right.
Okay, so let's see.
So is that language pretty much compatible with the JDBC right now, or it's totally?
Now our wire protocol is ours. So it's when you call a stored procedure, we need to take that stored procedure invocation. We need to serialize all the arguments, put it on the wire. That's all. That's proprietary but documented for how you interface with Volt directly. And then when your response comes back, it's the same thing. Your response has it's all serialized Volt table. There's some particular objects you have to handle. I can only assume at some point if someone really wanted to, they could make a JDBC wrapper for Volt, which would be taking, but it still wouldn't be able to take ad hoc SQL statements. It would just be taking Volt stored procedures. So I haven't seen a use case where someone spending that time would actually extract any value out of the back end. I'll show you one other thing. You can also use HTTP and JSON to call Volt stored procedures. So some languages it's just easier to do it that way instead of learning the wire protocol. So given that we have a lack of concurrency, talking about single-threaded and single partition and multi-partition work, bullet 2 here is something I really liked when I started to understand some of the Volt internals. You don't need to worry about locking and deadlocks when your stored procedure is executing. You have full control. If you're single partition, you've got full control of that partition. And if you're multi-partition, you have full control of all partitions. And that's a guarantee. You don't have to code around it, you don't have to think about it. What that does is, like this, it's really great for inventory type applications. You know, for an app where you want to check an inventory level and then create line items for a customer. Because you don't have to worry that after you check the inventory level and started creating those line items, did someone else come along and check the inventory level for the same item? And, you know, and how do you handle that? In Oracle, even though I was reading a table, I'd read it with a lock so that I would guarantee that no one came along and hid it behind me. Sure.
But that's assuming that that your partition, that your second statement, whatever it is hitting the same partitions as the first one. Otherwise, there's the possibility that
your store procedure is the transaction that begins and ends. So if it's all contained to one partition, it's all running right in this partition.
Okay.
If one statement has to hit one partition and the next statement has to hit another, that's multi. That goes everywhere.
I see.
So either way, you're the master of the partitions while you're running.
So then it's the flip concern, which is be careful within your stored procedure that you're not unnecessarily locking all the partitions if most of the work is.
Absolutely. You know,
okay.
key to Volt is think about partitioning, get a strategy, and have a partition workload. You can have a strategy and think about it, and if you don't have the workload, we're in memory. We still will be faster than most technologies, but it won't be anywhere near as scalable.
Right.
And if you're thinking about Volt, you should be thinking scale, not just, you know, for now if I run on one little server, I can run really fast because, you know, it's not the type of market we're going after.
You also could manage locking by the Java mutex Java locking mechanism.
Who could? We could?
Yeah.
Well, we wouldn't need to because when your store procedures
Or
running,
your customer can, that's potentially. Using Java locking.
Yeah, it would get kind of weird. But sure. I mean, you're running, you're instantiating a class in the JVM. You can do whatever you want in there.
Mm-hmm.
I learned the hard way about time zones with Volt and how the server, even though you tell it to start up one way, it actually can dream up its own time zone. And yeah, so I'm only about a year Java developer at this point. And I'm still there's so much to learn. I'm much more comfortable in the other languages that like Delphi is my favorite language. I can admit that in public. I love Delphi. I love me some Delphi. But I understand Delphi, and Java is just a little weird to me sometimes.
So from code reusability case, typically you would have procedures to do an inventory check and procedures to do that. Can you do like sub-procedure
Good question.
calling?
You're going to duplicate code, at least for now. Right now, a Volt store procedure cannot call another Volt store procedure. So the only way to reuse code is, well, I'll take that back. If there's reusable components that are not transactions in and of themselves, that could be reused. But meaning it has to be pure Java. If it has to call SQL, it has to go down to the execution engine. That has to be a Volt store procedure and has to stand alone. But if you have calculations that are common, that aren't database type operations, you can share that code. But yeah, you will. There's some cutting and pasting for some of the use cases I've worked on. Did you have a question?
Well, taking the inventory example, you know, if I looked at my sneakers and saw that I had 100 pairs, and now that's an atomic transaction,
Mm-hmm.
that's complete, and I don't have to worry about deadlocks if I say something like add 100 to my count of my sneakers, because I've just done inventory and I know that I've got another 100. But if I say change the inventory level to 200, from the time that I originally requested the data, which said you've got 100, somebody else could go in, because I don't have a lock on it. Somebody else could go in and change the balance to 150, and if I'm adding what I think is, I'm still going to run into that transaction problem.
Yeah, if you can't define a transaction as a Volt transaction that runs fully server-side,
Yeah.
and you need that level of control, you'd have to implement your own locking strategy.
Okay.
So you'd have to have a lock column or something.
Okay. Yeah.
Things that
Or-
can be
That's
great.
more of a user issue, right? That if you went to go update it and you said plus 100 or you said change it to 200,
I could also have as part of the procedure a double check to make sure that the original balance was 100 before I did the upgrade, or
Yeah.
you could all roll that into the stored procedure.
Yeah, because that just sounds like two people trying to do the same thing. One
Right.
person's increasing by 50, which would happen in anything. I mean, any database will allow you to add as many times as you want.
Yeah.
Was it like the compare and swap call, right? You compare that it's the same and then do a swap.
Yeah, but I mean, at least with a traditional RDBMS, you could acquire a lock when you did that first read, and you could hold on to that lock for a while.
Yeah.
Where you client side, you cannot do that in Vault. If you want to hold a lock, you're going to add a column to your table called lock with some GUID or something.
And then do something, yeah.
A lot of weirdness could probably ensue. But again, though, because of this lack of support for concurrency, needing to support concurrency and so on and so forth, reality, transactions in Vault execute in microseconds. So even though we're backing them up, they're backed up and running very, very quickly through the system. Okay.
I'm still thinking through like all this. There's a timing factor now to writing your programs, I guess, right? Because Vault has its own mind about what goes through. And it sends it out to different servers, and this one is waiting because there's something else happening, and this one is executing and so forth. So if you're programming, are you sitting there thinking about the timing and ensuring that takes up correctly? And
what I think about more than anything else is if I look at the transactional workload. So I've defined what am I working on right now? A proof of concept. I'm doing a proof of concept for a financial company. So I got their schema in my head. I know what their schema looks like, and they've got 5 store procedures, and I know what those 5 store procedures look like. If they're all single partition store procedures, they're very well defined and can be sharded in a traditional world, but they're partitioned in a Vault world. I don't think about anything. I know this application is just going to fly off the table. If every single transaction is single partition, that's right in the wheelhouse. That's a home run. That doesn't happen that often. So normally there's going to be 10 transactions that they run, and 1 or 2 of them are multi-partition. So what I have to worry about is how many of these multi-partition transactions at peak do they need to get through this system. If they need to do 100,000 transactions per second at peak globally for all transactions, but at peak they need to do 20 of these multi-partitions or 30. I mean, multi-partitions, they're the bane of my existence right now. And we've got lots of ways to optimize them and make them faster, but right now they certainly are not as performant nearly as single. So really what I think about is, in my use case, I have to make sure that data-wise and code-wise, that they're not going to try to get more out of Vault than Vault can give them. But I don't worry about like scheduling and how these things are flying around in the system. That's not something you have to concern yourself with, because again, when these things block, I mean, what's it blocking for? Micros. It's not blocking for a second. Like I used to write stuff in Oracle where I had to do lots of locking because I worked at a company where we did inventory management and we processed POS files. And while the POS file was going, I had to make sure no one else was processing POS files. And it took like 6.5 seconds to do that. And when I got it down to 5.5, I was so happy with myself that I improved it by 10%. But when I'm worried about numbers in this sense, then I don't worry so much about the backing up of a couple transactions. What I worry about is, am I indexed properly? Do I have a good partition strategy? And is there an even distribution of work? Because if any of those things are off, then your use case could go completely in the wrong direction. It's like any other database. If you don't have an index, then it's going to do full table scans. And it's fast, but it's not as fast as I'm used to. So if I have that happen, then I suddenly have to start plowing through my explain plans and see, I've got a sequential scan on this table when I thought I would have an index scan. Oh, and that's because, and I look at MySQL, I look at my index and determine, I need another index. It's like any other database with indexes. If the index supports the lookup, it'll use it. If it doesn't, it doesn't sequential scan. So the downsides of a lack of concurrency, other transactions certainly have to wait while the running transaction completes. B, don't do anything crazy in a store procedure unless you really have to.
Oh.
Don't request a web page, don't send an email. And then C, we're very, very useful for OLTP. I say not OLAP. There certainly is gray area between true OLTP and OLAP. We support 5 aggregate functions for a reason. There's some OLAP you can do in Vault, but some users I talk to, all I hear out of their voice is analytic, and I realize that they're not potential customer because they're going to try to use us in a way that it just won't perform the way they want it to. Throughput over latency. Volt was built from day one for throughput. We have great latency, but certainly we lead with throughput, and that's what we strive for. Some people I talk to, they hear that we're in memory, and they want to hear, do we have sub-millisecond latency? And I say no. You know, I'm in memory, but I'm not in process. I'm not times 10. I'm not, there's other solutions for those types of things. We're built for raw throughput on a cluster, not a monolithic in-process in-memory database.
Is it because of multi-partition? But if not, you would have a great latency? No. Not necessarily.
My latency is measured in mid-single digits. That example I said where we did over 3 million transactions per second on a 30-node cluster, the latency was about 8. I think that's great latency.
8 milliseconds.
8 milliseconds, yeah. The problem with how you define that is, if you talk to a high-frequency trading company, they need microsecond response time. And the only way you get that is you can't have a network. I mean, you have to be in memory, you have to be in process, and you're monolithic. You can't be clustered and pull some of this stuff off. So again, even though we're optimized for throughput over latency, I think we still have a great latency story. And the last thing here, I tell people, do not estimate latency as 1 over transactions per second, because some people do that. They say, if you can do 100,000 per second, why isn't your latency 1/100,000th of a second? It's just not. There's some queuing, as you saw in the slides. There's some batching that's going on. Data's got to get over the network. It's got to get to the right server, the response, and there's work to be done before we get there. SQL, as I mentioned before, reflecting on my MySQL friend back in 2001. So for SQL support, select is there, insert using values, not insert as select, update and delete. For aggregates, we support average, count, max, min, and sum. We've got materialized views for count and sum operations, hash and tree indexes, and that's it. So as it says here, SQL functions and additional functionality we're going to add over time. Really, as real customers come to us and request them. For now, I do it in Java. If I need to do a trunk or NVL, the SQL functions I'm used to doing right now, when I have to do them, I do them in Java.
If I ask about correlated subcores?
That's what I tell my developers. I show them the SQL I used to do, and they yeah. But
it's
first
not
on
for analytics, right? So you should need correlated subcores.
First on I want to merge, upsert, whatever you want to call that. That's an operation I think would be really useful. One thing that's neat though, that Volt does some things very, very quickly, and oftentimes instead of asking the developers, will something be fast, I just try it myself. So an example would be, I can probably write a SQL statement that selects 50 rows, bringing back 50 primary keys, and then batch, and then I could do 50 deletes on those rows. In almost the same amount of time, I could do a delete statement with a where clause. So some things Volt does, it does so quickly and so well that I always try them before I ask whether I should try them, because sometimes developers would just tell me no or not know the real answer and maybe lie to me. But knowing that, there's lots of operations right now. I work around not having lots of SQL functions and some of this functionality that people ask about. But it certainly is an area that every release on a roadmap, it says SQL functionality is an item, and I try to push for the SQL I would like to come in the next release. And then, as it says here, the execution plan for all SQL is created when we run the Volt compiler at compile time, and it's all in text files. I think it's JSON, available for analysis. It's easy enough to crack into those and look at it does a very, very simple, it creates as many plans as possible and then tests them for cost and picks a winner. So there's a bunch of winner statements that you could grab for your favorite tool and look for patterns of like sequential scans if you were nervous about performance. SQL and stored procedures. We took a quick look at a stored procedure. The important bullet here is SQL can be parameterized, but cannot and will not be dynamic. What that means to you, select star from foo where bar equals question mark. We can flip that in at runtime, but you cannot dynamically pick which table you're going to run from.
Can you do that in Java though?
No.
Like you can't say select star from dollar table or whatever. I
Well,
forget the
I'll take that.
variables.
I'll take that back for a second. We're store procedure interface. All your SQL's in your store procedures, and it can't be dynamic. So the right answer to your question is no.
You can't build the string of it?
The real answer is
Okay.
we have these special store procedures we call system procedures. They start with an @ sign. So you can, if you want to call snapshot, there's @ snapshot create. So there's these special things, and the developers would love to get rid of this one. There's a system procedure called ad hoc SQL. So you can dynamically take a SQL statement and push it into the system procedure, and what Volt does on the side, when it sees that SQL statement, it says, oh, my developers, told me these wouldn't come anymore, but here it comes. So often a thread, the server will take that SQL statement, plan it, and then execute it for you. The downside is performance. It's going to run multi-partition, even if it's single partition. The other downside is, while that's occurring, it's affecting your performance. So we want them there for development. We want them there for unit testing and quality assurance. In production, we seriously tell people to try not to do it if they don't have to. If there's an emergency and you had to, absolutely have at it, but it shouldn't be part of your workload, I guess is a good way to put it.
I imagine with all parameterized queries too, it's pretty much unattackable from like an SQL injection kind of a way. I mean, maybe you can squeeze Java over, but
I've said that in some of my webinars that you couldn't do SQL injection at our store procedures. The other day, I mean, ad hoc, there's a performance thing that all the developers want to push back on, and I'm like, these people own the cluster. They want to slow it down. They have a right to.
That's not true. You can do SQL injection on that if the question mark is the parameter.
Inject a parameter.
You can.
Yeah, you could.
You could.
How could I inject a parameter in that?
It's
It's not doing a text replacement. I mean, that parameter is an int.
But you could have a statement that says where foo text equals a parameter that's text, isn't it?
But remember, Volt pre-compiled all the SQL. So there's no SQL that could hop over the fence and get in there. That much is true. But an ad hoc could certainly be injected.
Right.
The other thing the ad hoc prevents you from is all that security you defined is out the window. If you tell a user that they're allowed to run ad hoc, you've got no control over what they're doing.
right. So then you can do SQL injection.
Yeah. And the other difference with Volt is we secure the store procedures, not the tables. So most systems you would have privs on the tables, and maybe even privs on the store procedures if you're Oracle. Volt, your privileges are at the store procedure level only. There's no privileges at the table level. So client apps connecting to the cluster. We've got a running cluster here with 3 servers. Client comes along and connects. The client can connect to 1 server, all 3 servers, just these 2 servers. Volt doesn't care. As it's issuing transactions, remember we've partitioned, so there's a potential that I'm going to issue a transaction to this server, but the partition for my work is actually over here. The server's smart enough to know that transaction came in, I'll accept it, I'll give it to the right server, server executes it, sends a response back to the original server, and then back to the client. So what's kind of unique and interesting about this as opposed to a traditional shard is the clients, not only do they not have to be aware of the partitioning strategy, they're just not. They connect to all nodes or one node, start issuing transactions, we get the work done.
Well, clients aren't aware of tables or anything because they don't connect to MySQL. It's all the store procedures. So you have basically, I also can imagine that you have all of you basically cannot, there's no way to combine your, say, business logic and data with like your look and feel or whatever, with your workflow, because you just can't.
Sure.
It's a good thing.
Right, yeah.
And then on this one, people have asked, if you get a big enough cluster where it really is more relevant in like a key value workload. If I send a store procedure to this server, and it has to be proxied over to this server to get done, and then proxied back, and then I get the response, A, it's more latent because there's more hops going on, but B, it's just more network traffic. So in the future, it's probably going to come sooner rather than later. We're going to bake into the response coming back to the client just a flag that says you either sent this to the right node or you didn't. It would still be on the client. So then if the client had a transaction come along and the client understands the parameter, and in the last 10 seconds it might keep track of what nodes it sent transactions to. It's kind of like a self-learning algorithm where the client could start learning where to send the transaction to the right place. And on a key value where you might be sending an 8K blob out and back, it starts to make a difference in terms of performance. On really small transactions, I've benchmarked it, and I'll be darned if I can really measure a difference between sending transactions to the right node or the wrong node.
Couldn't you just tell it the right node to send it to instead of, hey, you were wrong?
I
mean,
yeah.
the server you sent the query to already knows the right server it's going to go to anyway, and it seems like it might be easier just forward back, go to B, versus
Yeah, we could.
no, A was wrong, because it doesn't help you figure out which one is the right one. It just tells you which ones are the wrong ones until you get there.
That's why I'm trying to build community. I never even thought. I mean, that's a good idea. Or which servers were correct, because you're case safe and there's
exactly
additional.
with the dividing it up. Yeah, I'm also curious, like from a client, they could connect to any of the servers. Is there some strategy on the client side for load balancing failure there? If you go to a node that dies, you just say like point them at this node, and it'll figure out where to go.
In the client library in both Java and C++. So when I write my client app comes up, and I always have my client app connect to all servers.
Okay.
Once a failed response comes back, that server's taken out of the list. And the client library internally, it's just round robining. So as I issue transactions, I just say call procedure, and it says, oh, he's first, call procedure, he's second, call procedure, he's third. If he dies, he's out of the list, and we just work with the others.
So if you updated if you updated how many servers you have, would you have to go back to update the clients to tell them there's more?
Yeah,
servers?
we'd have to, and that might be part of an API call as well, where we might want to, at some kind of regular basis, feed some data back to the client to say, oh, by the way, such and such. We just had a rejoin. There's a new guy over here. You might want to add him back to your list.
Or
So
you
how do
could
you
just have them
cancel-
check periodically.
Where are you in the state of canceling queries and doing that with integrity?
What do you mean?
Usually in a distributed database of some sort, canceling queries is a problematic event. It's not always easy to know when all nodes have the cancel event. And that's just as big a problem as
Canceling a query?
canceling queries.
Almost seems like you just let it go. You don't want the result.
Well, no, not if you're serialized.
But in terms of so
I send a
What-
cancel
Okay.
command
So-
to my query.
well,
Gotta hit all the
your
nodes.
stored procedure, right? Not your query.
Ah, you have a simple problem.
Yeah, but remember, we support single multi-partition and we're clustered, so it's ACID everywhere or it's ACID nowhere. No matter what the stored procedure was, what it was trying to do, it either committed everywhere or it rolled back everywhere.
Right, but if you're doing like an update of a table and you're like, okay, update where 1 = 1, and you're like, oh crap, I don't want to do that. I don't think you can cancel it, right? Yeah.
No.
That's the
No,
rollback on
it's more the
steroids.
point.
Right, that's, yeah.
It's like
Right,
auto.
because there's no
There's no
once
client-side
you're
ask.
there.
Yeah.
It could be nice to have like in the API if you could look at the transaction queue and be like, take that one out, didn't want that one,
Yeah,
or
but
something.
100,000 transactions is so.
You don't have a lot of time.
Yeah, it's already been done by the time you realize that you don't want
I was going to
to.
say the network.
I'll wait another
latency just to get
100,000
that packet. Yeah.
All right, so I may still not be getting, but let's talk about cross-node communication. You don't
Okay.
want to do that a lot, but sometimes, that's what you have over a NoSQL solution.
Yep.
You can do it, and you have to land a lot of data from one node on the other node for, say, a join of some type.
Yep.
Is that a screw case for you, or?
It works. I mean, if you want to issue a multi-partition transaction and go get a bunch of rows from a bunch of partitions and do some aggregation, the result back to the client, you'll be presented with a single row set, which is what you wanted in the first place. Behind the scenes, what's going on is you put your transaction out to this node, it's assigned it to one of its partitions.
Yep.
That becomes like the master of this multi-partition transaction. It sends info out to all the partitions, and if they're all doing selects and they're all bringing back row sets, that's still a pretty good use case because let's say there's 18 partitions, it gives it out to the other 17, and those other 17, all they have to do is get that work done, get those rows, and give them back to him. They can get on to other work.
So that's the easy one.
If they do read-only work, absolutely. Or even if they're doing update statements and they haven't actually modified any data, they can just move on. There's nothing to roll back. I don't need to wait for a commit or rollback. The hard one is I've done insert, update, delete. I've actually modified data, so I got to report back to him that I'm done, and I still have to wait for him to say that everybody's done, and then he gives me the message to go. It's like a two-phase commit. There's really no magic way to do that any better than that. And again, that's why we want, single partition workload to be in the high nines and the multi-partition to be in the low, unless it's read-only work. I mean, there's some use cases where it doesn't make that much of a difference, but.
And that original node that orchestrates all of this, does it know which node has to do what? Or does it just put it on the wire and the node that can do it?
Currently for multi-part, everybody gets the work.
Yeah.
I've been going back and forth with the developers because what I'd like is, right now it's binary. You're either one partition or all. I'd like two. 1, 2, and all, because there's a lot of 2 partition use cases. Banking, transfers, eBay, PayPal. I mean, there's a lot of use cases in the world where at 2.
Even some. I mean, even just kind of send it to all the partitions and they can say, okay, I don't have this. I don't have any ID equals 3. I like your original one, right?
Well, they do that. They race as fast as they can to come back with an answer. And if it's a read-only transaction, the coordinator knows that's it for the stored procedure. There's nothing else to be done. And they move on to other work.
Right, but it would be great if in the queuing, if in the queue it could say, okay, I'm not going to wait until all the servers are at this one to run this transaction. I'm going to run it now when I get to it. Let's say, partition 3 is ready to
if it
run
gets to that point in its queue, it'll do the work and wait, because everyone behind it has to wait anyway.
Right, but what I'm saying is if it does the work and says, okay, there's nothing to be done here because I don't have any of these, instead of waiting.
We call that speculative execution. That's coming in the end of the year.
Great, okay. So then that will basically effectively do the sum.
Yeah. Well, the other thing with speculative execution is, even if let's say I did updates, right? I could send a message back to the coordinator and say, I'm done, and I could actually start doing the next transaction in my workload. And I can go on and on. I could have a redo log. I mean, there's a lot of special sauce that's coming for those types of transactions to make them faster. Because right now we have single part and multi-part, and our goal is to bring multi-part as close to single as possible. All right, schema changes. Probably you were wondering this, but no one's asked yet. So traditional OLTP, I missed this. Add table, alter table, add index, drop index. Add column.
I was guessing you recompile and then reload. Yeah.
So you modify your schema, modify your store procedures, build that catalog, and then one of those special system procedures is called update catalog. So what that'll do is take a new application catalog, bring it up and in, compare it to the existing one. If tables are now missing from that catalog, it does a drop table. If store procedures, users, you name it. So currently we support adding modifying users, modifying store procedures, and adding and dropping tables. We don't currently support adding and dropping individual columns on tables.
So can you export your current view of the schema?
So, but how do you alter the table? Just adding indexes?
We support add table and drop table.
Oh.
You can add an index, you can drop an index. You cannot add a column, you cannot drop a column. My only workaround for now, if you needed to add a column, you're going to add a table with a column.
And what's deploy catalog? Is that the same kind of build from the snapshot as if?
No, so what you'd have a running cluster, and over here your developers, they came up with version 3.x of your application. So that when it's all said and done, they're going to create a jar, which is the new application catalog, which contains your schema, your users, all that fun stuff. You take that jar file and you deploy it into your cluster, and then it basically does a diff on the existing schema and the new schema, and based on that it knows, oh, here's a new store procedure, I need to add it. This store procedure didn't come in this new batch, it's gone, drop it. This table's new, add it, this table's missing, drop it. This table exists and it was already there, that's okay. This table came along and has an extra column. Oh, we're not doing this at all. Reject it, send it all back.
Oh wow, okay, wow.
But it doesn't like do it all in increment. I mean, it makes sure it can do what it needs to do, then it does it, as opposed to getting halfway there and then having to roll it all back.
But it's basically is it pretty quick? Like let's say you, I don't know, yeah. I guess it's pretty quick because you.
10 milli, maybe less, depending on what you're doing. Yeah, it's very, very fast. And all that work only has to be done by one node. It's not like everyone has the same catalog, so one guy coordinates it, validates that everything's okay, and then it's a transaction. It pushes it out to all nodes and says, at this global transaction ID, we're going to switch the catalog, and everyone switches at the same exact time.
So basically, you can add and drop a table, but anything that you're going to do to change the table is a drop and add also. So like if you were going to do, I understand adding columns, dropping columns, but even things like changing attributes for a column, that's a drop and add table.
I will change my answer.
Okay.
You can resize columns.
Okay.
So columns can always get larger,
Okay.
or be a greater int type. They can get smaller as long as all the existing data fits within that smallness. But yes, you can mutate your schema from that perspective. To do anything more complicated requires a service window. You're gonna down and up.
Yeah.
What determines things like out of range data? Is it Java or is it the SQL itself, or like let's say I want to insert a A into an int field.
That's gonna die down in the execution engine. So it's gonna if it's range in terms of size, like an int type, you're trying to put a bigger int in. I mean, there's going to be lots of checking that's going on at the Java layer, but there certainly are some things that you could, like if you pass in a varchar, which is a string in Java, it's not going to do a length check, I don't believe, until it actually attempts that update statement, which will fail in the execution engine, roll back the transaction, and come back to you. A lot of the int types and things are going to be handled as the data gets passed from the client to the Java store procedure prior to actually going into the data. Because in Java, if you're using an int as opposed to a long, then the parameter type to your store procedure is going to be an int. And if you try to pass a long, Java's going to say, no, this is an int type.
Constraints, referential integrity?
Good question. Constraints. Uniqueness, so we've got primary key, unique indexes, data type constraints. We do not have foreign key. So if you need to enforce foreign key right now, you're going to be enforcing it in your store procedure. Do a lookup, make sure the value, the foreign value is there before you do your.
Usually, for such a speed, that referential integrity is not the highest priority.
Our belief is that it's not doable, but we're not going to rule it out. But it certainly would have an impact on your performance.
That's my summary.
So that means the BI tools won't work with you.
Well, we don't have a
And
JDBC
they
ODBC
shouldn't.
interface.
And the BI tools shouldn't, because it's not for OLAP.
Good point. Report writers, crystal report.
So back to the schema V10, which was released in May, add drop users, store procedures. And 1.0 actually had the question you asked about types getting larger and smaller. 1.1 added add and drop tables and future add drop column and other things that we haven't thought of yet for schema change. Table and index storage, VoltDB is entirely in memory, meaning the cluster must collectively have enough RAM to hold all your tables and indexes. And again, it's got to have K+1 copies, as a couple of you guys have caught on to. An even distribution of data is important, and what that means is if you've got 10 servers and each server has 50 gig, your data is going to be partitioned amongst those servers, but if your data is skewed such that 90% of your data has the same partitioning key, then it's just not going to fit. It's going to require way too much memory from that first server, and it's not going to work. You don't need a perfect distribution of data, but there should be some evenness. Otherwise, you're going to have to build very large servers, and many of the servers will have a lot of memory that's not used. A little bit about migrating and developing. I put a little comedy here. I don't know if you guys will think it's funny or not. So take your existing DDL, your SQL, your store procedures, compile your Volt application. No, not so much. DDL's great. It's very, very helpful. I'm doing a POC right now. It's an app they did in MySQL. They're going to give me all their DDL. They're going to give me all their SQL. And then we're going to start talking about store procedures. Certainly a very good start, probably better than having a specification for most applications. But what you're going to do is you're going to review your app as a whole. Look at your whole data model. Look at your transactions, be they in a Java application, in PHP, wherever they are. You really need to think about your data and think about your transactions to see if you have something that's a valid Volt use case. Partitioning is huge. If you can't partition, then Volt is a very good database that won't scale beyond that first number you get in your benchmark. So if you can't partition and you're happy with the number and you're never going to grow past it, I'll give you a pat on the back and let's keep moving forward. But if you have an unpartitionable workload, it's probably not worth the pain of migrating to Volt from something else. And then just be thinking about your stored procedures, because that's where everything is going to go. All your SQL is going to land in these stored procedures. So look at your schema, define it, think about partitioning, look at your transactions, build some stored procedures. And then, as I mentioned, think about your SQL requirements. If you've got an app that's got tons of really nasty, complex SQL, you're going to be spending a lot of time making that SQL work in Volt if your use case hasn't changed since that SQL was built 4 or 5 years ago. Certainly, a lot of your project could go toward making your SQL Volt compliant in the current version of Volt, as opposed to in the other areas of development. For client libraries, we support Java and C++ natively. We've got a native PHP client that was built using the C++ client and Swig. Thanks to Swig, we can produce many others. The downside, does anyone know Swig or has played with it?
Yes, you can do Perl.
Yeah, so you write a C++ client library, a C++ application, and you do some things to make Swig very happy with it, and then Swig will target many, many languages: Perl, PHP, Python, I think C#, maybe Delphi. You never know. The downside to it is the client, the native client libraries it produces. They're basically wrappers around C++ libraries, but they're not as friendly as if a PHP developer had a native PHP library that was built in PHP versus we gave them the C++ Swig version. They're going to see a difference. It doesn't always capitalize on all the features of a language, but it's certainly good enough to get started in some of these languages. Our long-term roadmap is to have a true native PHP, Python, C#, and potentially other language support for clients. In the community, it's one area where we've had some help from the community. A fellow in Germany who's a game developer wrote an Erlang client library and forced me to learn Erlang, and it was very, very painful. Erlang's not fun. And someone over in Japan has built a Ruby wrapper for our HTTP JSON, and he also claims to have a native wire client, wire protocol client in Ruby that he's not willing to share yet because he says it's in pretty scary shape at this point. He checked in his the Ruby one he did into gems, but he wants his code to be a lot tighter before he checks in the true Ruby one. And then, as I mentioned, a great way to access Volt right now, especially in the proof of concept stages, is just using HTTP and JSON. It's easily called and used by most languages, and currently our servers can handle about 1,000 of these requests per second. Nowhere near the number they can do when they're speaking the wire protocol. But this is an area where we're just going to have constant development to make this interface more performant. Our hope is by the end of the month to get that up to around 4,000 or 5,000 per server, and then long term to look at strategies to get it closer to the wire protocol. Getting data in and out. There's one option right now. Create a simple client app that reads flat files and loads them in tables. Lots of examples of this. They're very straightforward. You can write a single, if you have very simple stored procedures that are just a single SQL statement, we have a project XML file where you can put that SQL in the XML, and it'll build the Java class for you. You don't even have to write the Java code to do it. Eventually, it's one of my dreams is to have a generic utility similar to SQL Loader or tools that I'm sure are available from MySQL. So you can have flat files and metadata about those files, like delimiters and data types and columns, and do it all without writing code. But for now, we're writing small client apps. Getting data out. One way to do it is take your snapshot, and we've got a utility right now that'll convert a snapshot file to comma or tab separated data. So dump your database using a snapshot, pick the tables you want, and then run it through this utility to produce your data. The other way out is EL, and this we talked about a little bit. There's a special table type in Volt called an export table. So it's either export, supporting insert, update, and delete, or export only, which supports insert only. In your store procedure, you're operating on these tables. When those store procedures commit, We have a special type of client application that can read from special buffers in the servers and be pulling out this committed export data. And it's actually a two-phase process in that the client app can come along and pull the data, do something with it, and then the client app actually sends an ACK back to the server to tell it that, yes, that data is now durable somewhere else, you can remove it from your buffer. Just in case something goes wrong between, if I pulled from the buffer, I went to do the JDBC, I crashed, we want to make sure that that data is not lost. So there's an acknowledgement back to the server to drop the data.
I assume the export is much, much slower than export only.
Speed-wise, it's not different. The difference is really going to be the noise. Because it's, if you think about it, all we're doing is when I'm inserting, deleting, or upsetting from that table, those tuples, I want to make an extra copy over to this buffer. It's all in memory. Versus the export-only table, I can only do an insert, and that insert's going to get copied over to this buffer.
Why then?
Why have both? Export-only is great, like for that package tracking example, where UPS only wants to bring the entire history of the package over. The nice thing about export, if I had a system that part of it was the system of record for my company, like maybe they were modifying my my inventory category catalog, and I want to make sure every change over here goes over there. It's an easy thing to do. Initially, we did export first, and then we realized export only was probably important, so we added that as a feature. But I think the code paths are very similar. And as it says here, currently we only dump to the file system through this EL connector. We're going to be doing JDBC at some point. And it's one of those things, hopefully a community member comes along, needs it, and wants to get involved. So Q&A, we're at voltdb.com. Come take Volt. Register, don't register, whichever's fine. Lots of sample app code to look at. Join the community. We're trying to start some user groups. We're on Twitter at VoltDB. We've got a community side of our site with forums for community support. And then there's my contact info at the bottom. Either email, Twitter. You can get in touch with me if you want to play with it. You know,
So what's the cost, since you mentioned?
Cost, GPL v3 is free. And right on the website, voltdb.com/pricing. Open source and commercial. Differences are, the support for the community version is in the forums. Right now, we don't have a ton of commercial customers, so if you want to play with it right now, it's free. I'll support you, the developers support you. Eventually, we will get to the point where email support and phone support is commercial. But the price is $15,000 per year for a 4-node cluster. So the way Volt is sold, it's an annual subscription. You're not buying the software and paying maintenance and for maintenance and support, you're paying an annual subscription. 4-node cluster is $15,000, and then as you add nodes up and beyond that, it's instead of $3,700 a year, it's $3,200 a year for 5 through 12, and then 28 through 13 and above. And if you've got a 13-node problem, even with K2, I mean, you're doing 800, 600, I mean, just crazy transactions per second at that server side. And really, right now, the version 1.1, the products are identical. The open source and the commercial are indistinguishable from each other. The very first commercial feature we're putting in is in the release coming at the end of this month, and it is around management and monitoring tools. So there's a web-based UI where you can start a cluster, stop a cluster, take a backup, check the health of the cluster, some kind of surrounding tools like that. The release at the end of the year, next spring, that's where some of the features are going to kind of diverge a little bit, and I think really where the initial focus on the commercial version beyond these external tools is going to be around these multi-partition transactions. A, and B, that recovery that I talked about. So right now, free and open, end of this month, maybe takes 2 minutes to recover a node. I can see that as a feature that potentially, if we can get that down to almost instantaneous, is probably going to be a commercial feature. There's going to be little things like that. But internally, I can tell you the developers fight very hard. And when I say the developers, the Java, C++ guys, every time we go in a room and start talking about roadmap and features, commercial versus open source, they do everything possible to take every single feature and make it free and open source. A, because they believe in free and open source, and B, selfishly, because they don't want to maintain 2 code bases. I can see the other side of it where it's like, And it's not just a pain in the butt, it's how much work can we get done? How many new features can we add, the more we have to fork some of our code. Any other questions?
Great, thank you very much.
Thank
Yeah,
you.
and as I said, I mean, if you're curious, you'd like that question exactly, that's what our forums are for.